I got a question recently from a viewer called Gayeth Altrabusi, and the question was, could I explain a little bit about the idea of task.fromResult? And it's really interesting this because although task.fromResult ultimately is quite simple, we need to understand a lot about how async and await and tasks work before we can get to that point. So it's quite a lot to cover before we see that final answer. Now, I've already done a video on the basics of async and await, so that was done quite a while ago. If you want to have a look at that, that will just get you to the starting point for what we're looking at here. But we're going to go into a bit more depth in this video, and indeed the next one. I'm going to split this over two because it's getting quite complicated. But what I wanted to introduce was 5 basic rules, almost, not quite all of them rules, but statements about how async and await and tasks work. So let's have a look at those. And the first one of those is you can only have await inside an async function. So let's just take a look at that. I've got a quick program here where basically I've got this class called serviceAccess, and it has a method called getDataAsync, which is an async method returning a task for string, and that makes an async request to this website here, gets back the response, so it awaits on that, and then it makes another async request on the await to unpack the contents, and that's what gets returned to the program. So the program simply calls that, prints out the result. So if we run that, then we simply see there is the content of the whole of that HTML page. It doesn't really matter about that. But the point was, it's using async and await. And so that first rule, the idea that we can only call await from inside an async function, that's pretty simple. If I miss off the word async there, then we get errors on both those statements with the await telling us that we can only call await inside an async method. So that one's pretty straightforward. The second rule is that an async function can only return either void or task generic for t, or what is known as a task-like object, or iasync enumerable for t, or iasync enumerator for t. Now, we covered the iasync enumerable in an earlier video, so we're not going to concentrate on that here. The basic principles are the same, but you can have a look at that video if you want. But let's just look at those other ones. So again, if we go back to the code here, so there you can see we are returning a task for string. We could return a void. Obviously, you get an error there because it's the wrong type, but it's still allowed up there. But if I were to try to return something like an int, then we get an error on the declaration itself, basically saying what I've just said, that the return type must be one of those things. The third rule is that an async method should contain at least one await statement. Now that one, you only get a warning. It's not completely illegal, but it is regarded as best practice. So if I were to get rid of those momentarily, and just for simplicity, let's make that void. And what we now get is a warning, basically saying that you've got this as async and that it's missing an await. That's not completely illegal, but it's just not a good idea. The fourth rule seems actually to be in contradiction with the second one, because although the second one says we're allowed to return void from an async function, actually, in all but very, very limited circumstances, it is a bad practice. It doesn't give you a warning even if you do it, but it's generally frowned upon. And that's what we're actually going to be explaining in the second video, so that one we'll just park for now, not worry too much about it. But then the fifth rule is that async is not part of a function specification. And once you understand this, this is certainly when I was first looking at these things, the one that it didn't quite click at first, this will really help you to understand how to use async and await and tasks. So let's have a look at that. So what I'm saying is this async is not part of the function specification. And we can demonstrate that in a couple of ways. One way is we could try overloading on the basis of async. So if I put another function in there like that, and then just give it some silly return statement, not going to make any sense there, but the point is that this second one is basically saying that it's already got something with the same parameters. So you can't overload just on the basis of async. Perhaps more importantly though, it has an effect if we're dealing with interfaces or base classes, because if I introduce an interface, so let's do an extract interface on there, just do it all the default, but if we then take a look at that interface, you'll see that although it's extracted that method, it has not put the async keyword on there. And indeed, if I did put that on there, we get an error that's telling us the async modifier can only be used in methods that have a body. So it's not going to work on interface methods or on abstract methods. And so that's what I mean by it not being part of the signature. So when we've got our interface that's returning a task, when we implement that interface, we're actually at liberty, and we'll see exactly when you do this later on, but we're at liberty to decide whether we're going to implement it in an async way or not. You've got to implement it with that task return type, because that's the return type from the interface, but whether it's async or not is something that we get some choice over. And so now if I put that as the interface, well, now we can see that this get async data, although it's awaitable because it's returning a task, we don't know whether or not it's an async function because we're accessing it through the interface, and the interface doesn't have the keyword async on there. And in fact, we could make that even clearer because we could always split this up. So here I could say something like var task equals the method call without awaiting it. And then here I could say var text equals await task. And so again, you can see that when we do the await, it's completely separated from the function call. It's the task we're awaiting, not the method call. In fact, all the async is doing on a method is what we saw in that original video. It is breaking it down into a number of small chunks that will be called one after the other on the worker thread. So the first chunk will be everything that happens until the first await is completed. The second chunk, everything that happens until the second await is completed. So it's not telling the caller anything, it's restructuring the internal workings of the function, and whether it's async or not is completely invisible to the caller. Just to go back to that rule number 2, remember in rule number 2, amongst the things that we said you could await a task-like object. And what we mean by that is, let's just do something like declare an int x and then try to await x. And obviously we get an error there, and the error message we see is saying that the data type, int in this case, does not have a method called getAwaiter. And that's actually the key defining rule. So when we talk about a task-like object, it basically means an object that has that method getAwaiter. Now in theory, you could do this for yourself. You could write your own class with a getAwaiter method, but in practice it's something that's only done essentially by the compiler writers themselves in .NET. It's not something you'd ever have to do for real. So although strictly speaking we've got this idea of a task-like object, it's not something you'd ever worry about. We're just going to be dealing with tasks. Another thing to notice while we're looking at this is that although an async function can return void, you cannot await a void function. So if I were to just quickly change that to void and then go back to our program, and then let's just try to await that, then you can see cannot await void. So although void can be async, you cannot await it. And that's really the problem that I was mentioning. That's what we're going to look at in the next video. So for now, let's just leave that as it is, set that back to returning a task, and set that back to what it was. So it should be working the same way now. Now, once we've got that task separated out, so we're returning the task and then awaiting it separately, that means we can start having a look at what that task is telling us. So if we look at a task, we can see that it has got actually these 4 properties, all beginning with is cancelled, is completed successfully, and is faulted. And so what I could do is just do a console write, and then let's say is completed, and then we'll take a look at task.isCompleted, and then let's just copy that out to do the other one. So we had is completed successfully, we had is cancelled, and we had is faulted. And just copy those over. And then let's just get rid of that last line because it will just clutter up the output, and run that up. And we can see that before the task has been awaited, all of those are false. So it's not completed, nothing's happened because it's not executed at all. If we take the same code and put it after we've done the await, and let's just put in a blank line so we can see them apart, then we'll see that the is completed and the is completed successfully have both gone to true. So that's basically the task is now saying that it has completed. And that's essentially what the task await does. So we can await it because the code that's generated from that await will start looking at the task and looking to see whether it's completed, and will only pick up execution when it is completed. Now, obviously in this situation, that is pretty straightforward. When we get hold of the task, it's not completed. When we await the task, it is completed. But there can be situations where a task is completed instantaneously. Let me just show you that. What I'm going to do here is I'm going to pop this into a loop. So I'm just going to say for, and then int I equals 0, and then we're just going to go up to 2, put that all in a loop. And then what I'm also going to do is just pop out another message so we can see which thread we're running on. So let's do a thread and then environment dot current manage thread ID, and pop that again in there. And I'll just pop in another blank line. And so now when we go through that, we can see obviously it goes through twice. So the first time the completed is false. We switch to a different thread when we do the await, and completed is true. Then just the same process again. So we pick up on the same thread, but of course once we await, we've got to go to a different thread and it comes out true. But that's not something that's always going to be the case, because what we could do is something like this. Let's actually cache that result. So what I'm going to do here is put in a private nullable string that I'm going to call cache. And then in here, we can say if the cache is null, then we're going to set the cache to that response. And then at the end of it all, we just return the cache. So first time we come in here, the cache will be null. So we make the async call. And then the second time we've already got it, so we just return. And that's something that's worth noticing. That means although we said you get a warning if you have an async function that doesn't contain any awaits, that doesn't necessarily mean that those awaits have to be called. So in this case, the second time we come in here, the awaits are going to be ignored because we're going to go straight to returning the cache. But what that means if we go back to the program is now we can see some slightly different behavior. So we start on thread 1 once again. Obviously we haven't yet accessed the website, so this comes as completed as false. We switch to a different thread, comes to completed as true. Then we pick up on the same thread, but this time, as soon as we get hold of the task is already complete. And it's already complete because we've not had to make an async call. We've just returned the cached value. And so that's what's happening there, that we get true out immediately. And therefore, when we do the await for the second time, it doesn't blink an eye. It just carries on in the same thread. It knows it's already got the data because the task is complete. And so it can just finish off and we can see it doesn't change thread, doesn't change state. So that's something that's worth remembering. Whenever you await a task, there is the possibility that that task might already be complete. And so there will be no special processing, there will be no jumping between threads. It will just give you the answer back. So you should never assume that you're definitely going to end up on a different thread after the await compared with before it. So that's the idea that we have, that this task is telling the system what the status of the thread is and all that sort of thing. Now looking at those other properties, is cancelled is all to do with cancellation tokens, and that's something I've really been meaning to do a video on for quite a while, so that's something we'll come to later on. Is faulted is all to do with exceptions. So let's introduce some exceptions to see what's happening there. So let's get rid of that for loop again. And let's introduce some exception handling. So I'm going to put a try block around there. And then on the end of that, we'll catch an exception. And we'll just print out the exception message. And then what I'll do is in my service access, let's just change this so we're trying to access a non-existent website. So just throw some garbage on the end of that. And if we now run that up, then we should see that we start out with the completed as false. So that was being called at this point. But then when we do the await, throws an exception. And so we end up down here and we're getting the message printed out, no such host. But it would be interesting to see the state of the task once that's happened. So let's grab all of that code and pop it in there. And then also you'll notice we've got a slight problem because the task is actually declared inside the try block. So let's just take that outside the try block so that it's in scope. And now if we run that, then we'll see that there we get the exception. And now we can see that completed is true, but completed successfully is false, and is faulted is true. So you're going to get that is completed because it's no longer running, and that would happen whether it completed successfully or whether it was cancelled or whether it was faulted. So if that first one's true, you'll get one of the following three to be true. And so that's what we can see there. So again, that's how it's indicating to the outside world what is going on. And once again, the await is looking at that information so that the await can throw the exception if necessary, because the task itself, if you just threw the exception straight from there, well, it wouldn't be caught at this point because the task is running asynchronously. So that's why we have to have all of that information. And that kind of relates to why it's so important that we do return a task, not void, from an async function, because if we return void, how are we going to know if there's been an exception? And that's really what we're going to look at in the next video. Just a few other things, because we're still trying to get back to this original question, what is task.fromResult all about? So we've seen that if you have an async method, it may turn out that although it has awaits, there will be circumstances when none of those awaits is ever called. And you can see that worked perfectly well, and we looked at some of the issues, but that was all working fine. But let's actually suppose we do something different, and let's go and add another class which is going to mock that interface. So I'm going to have a mock service access, and then I'm going to implement that interface, public, and then colon I service access, and put in the method. And you'll notice that by default it doesn't put async on there. Remember, we saw in the service itself it knows nothing about async, it only knows about task. And it's something that kind of instinctively you think, well, this has got a task, it must be async. But then, because this is a mock and it's not actually going to call the website, it's got nothing async to do. So you might end up just doing a return of dummy data, whatever it may be, for some kind of unit test or something like that. And you can see we're getting that warning again that the method has been declared as async but hasn't got any await statements in there. Now that is still going to work. So if we go back to the program and we replace that with our mock service access, so let's put back in our output statement, and if we run that, we can see we've clearly got a thread that's coming back immediately completed because there was no await in there, and we've got the dummy data coming back okay. But that's not a very satisfactory way of doing things. The reason it's giving you the warning is because there is an overhead to having an async function. So it's got to set up all of these callbacks and that sort of thing, put in the infrastructure for that. But if you've not got any awaits, then all of that is unnecessary. So what we can do instead is get rid of the async, and instead of returning string, which you can't now because it's the wrong type, this is where we come to what the video is all about. In essence, we say task.fromResult and then pass in the dummy data. And fromResult is a generic. It determines that you've passed in a string, so that's the type returning. And so it returns a task that is already completed that contains the result of dummy data. And so it now means that back in our program, it will behave in the same way as when we did it async, but without the warning and without having gone to the overhead of setting all the async stuff up. So if we run that, we see we're getting the same results. So it's immediately true. So the await just runs straight through, just like we had with the cached one, and we get the results out there. But we haven't wasted any effort at all in putting an async on there when we don't need it. So that's really the answer to the question. We've got to bear in mind the fact that because async is not part of the specification, then if you've particularly got a situation with an interface, although the method on the interface may very well return a task, and therefore there will be some implementations for which it makes sense to be setting that function as async, there could be other implementations which don't require it, and therefore to give it back a completed task, we just do this task from result, pass in the data, and then that will immediately return the completed task and everything can get on its way. Just one last thing you might want to consider. What if we have a method in our interface that is simply returning a task, so which has no return type. So we just call it that. And then if we go to our mock object and we implement that, then again, obviously we don't want to make it async. So what do we return? Well, you can say return. You might want to think, well, we want to say task dot from result, but with no parameters. So like if it's a string, you do task dot from result string. They could have done it like that, but it's not quite done like that. What they have is, there is this special one, task dot completed task. So as the help says there, all it does is give you a task that's marked as complete, just like from result gives you a task that's marked as complete. But in that case, it's a task generic for string in this case, whereas here it's just a task. So that's just the one extra bit to fit everything together. So I hope that explained quite a bit about what's happening with tasks and with async and await, what the relationship is between them, what task.fromResult is, but also why we don't always put async on a method simply because it returns a task. You put async on a method if it contains an await, but you don't put async on there just because it's returning the task. Next time we're going to look at this quite rare but occasionally important idea of having an async void. But for now, hope you enjoyed that. Do subscribe, do click like, and I'll see you next time.